The last part of 5.4 looks at the difference between the net area and the total area, and an application of that. So let's say you have this curve f of x, and the area under the curve between the curve and the x-axis in terms of positive numbers is 5, 3, and 1, like the picture shows you. So if the question is, what is the integral from 0 to 10 of f of x dx, then the answer is 5 minus 3 plus 1. Since this is area under the x-axis, would give us a negative contribution to that problem, and that would give me a 3. On the other hand, if we had the integral of the absolute value of f of x dx, now it would take the curve and make the curve positive everywhere. So the curve would now follow this top part. It stays positive. When it would have gone negative, it would just kind of be positive instead, and then positive again. So now it would be 5 plus 3 plus 1. Or you could think of it like this. The integral from 0 to, well, let's call this a and that b. The integral from 0 to a of f of x dx minus the integral from a to b of f of x dx plus the integral from b to 10 of f of x dx. So the reason we have this minus here is because the f of x from a to b is a negative number, so that minus takes care of the sign here, and it makes each of these values positive values. So why would we ask the question, what is the integral from 0 to 10 of f of x versus what is the integral of the absolute value of f of x? Okay, so the kind of classic example is the difference between distance traveled and displacement. So if f of x is measured in feet per second, what does it mean to have a positive velocity or positive feet per second? If I think about this, if I said, okay, here my curve is a positive feet per second, but if I find the area under the curve, I'm talking about how far I've traveled. I think we saw an example of that in one of the previous sections. So from 0 to a, you travel 5. What would it mean to say that from a to b we travel negative 5? Well, that means we're moving in the opposite direction that we were moving. So when the velocity is negative, it's going opposite our reference point, so compared to the positive. You can imagine, like if you're walking and you have a positive velocity, you're moving in that direction, but then if you have a negative velocity, you're moving in the other direction. So if I said, okay, you've gone 5 that way, and then you go backwards 3, and then you go forward 1, the displacement is how far have you gone from the start to the finish. That is your displacement. And our displacement is the integral from 0 to 10 of f of x dx, and it was 3. Right? You went 5 that way, back 3, forward 1. So from here to there, you could have just gone 3 instead of forward, back, and then forward. On the other hand, if we want to know what the total distance traveled, then that's going to be the integral from 0 to 10 of the absolute value of f of x dx. So we've traveled 5, we've traveled 3, and we've traveled 1. And That adds up to 9. So displacement is how far away are you from your starting point, and total distance is how far have you traveled along a number line. You can kind of think of it that way. So in order to find total distance, you're going to have to watch out. You might have to find zeros of a function to make the part that is negative to make it positive. So one last example. If you've got a function that looks like a parabola, like so, and let's say we're going from 0 to 5 here, and let's say there's an intercept at 1 and 4. If I wanted to find the displacement, then I would just integrate from 0 to 5 of f of x dx. If I wanted to find the total distance traveled, I would need to integrate from 0 to 1. That gives me a positive, so that's okay. Minus from 1 to 4, since that's area under the x-axis. And then plus from 4 to 5, because that is a positive above the x-axis as well. So I want to find that area using from 0 to 1. I want to find that area from 1 to 4, and then that last area from 4 to 5, keeping in mind the signs.